Hello.
Welcome,
It's
welcome,
really
Dmitry.
pleasure to be here. Thank you, Maxim.
Dmitry is a veteran of Microsoft. He works there for more than 13 years. I work only 2 years, so I'm just a newbie there. Multiple roles: developer, evangelist, software developer, and I know that you can often see Dmitry on the stage of the conferences. I believe virtual ones now, like Cloud Builders. I know that there are multiple articles of Dmitry on a cool resource called Habra, and maybe on some other resources. So, Dmitry, what are you going to present us today?
Well, today, even though it's a .NET session, I will not talk so much about .NET. I will talk more about the cloud, and I will talk about the recent demo that I made of using different cloud services to mine extracts from COVID papers dataset. I think that's really interesting topic because it's actual and it also shows a lot of different cloud technologies. So that's what we'll be talking about today. This presentation, by the way, was prepared together with my daughter, who is now almost about to finish her school. She helped me with some development, and if you want to see the slides afterwards, here is the link here on top of the slide. They are available online, so that's essentially one link that you can take a picture of or remember or open immediately to have access to all the slides. So the idea of this demonstration is pretty simple. Since the beginning of coronavirus pandemic, there have been published about 400,000 scientific papers, which is a huge amount of information. And if a person wants to do some meaningful research on them, he needs some kind of tools to like at minimum search them in some intelligent manner, or ideally to extract information from them, not to read all of them, but gain some insights and maybe even some answers to his questions. So all of those papers are available as the dataset called Cord19. It's available on Kaggle, and you can then try to think what a data scientist can do with it to help people get some insights out of it. So the idea that occurred to us, and it occurred actually to quite many people, is to try to extract some information from this corpus of text. So the idea is that we can use a resource called service called Text Analytics for Health. Microsoft was quick enough to provide the cognitive service, which can indeed process medical information and extract some entities and relations from it. And those entities and relations, they come in hierarchical form. So we extract them and store in Cosmos DB database. And then we can do different things with them. We can visualize them using Power BI. We can do SQL queries. We can do some powerful semantic search. So that's the overall idea of my talk. And let's start exploring those steps one by one. So first of all, let me tell you a little bit about Text Analytics for Health. So Text Analytics for Health is currently in preview. It's very young service. You can imagine it came around due to the high demand of a lot of medical information available. And this service is currently gated, meaning that to get access to it, you need to apply and explain your business case and specifically get access to this service. The reason for that is Microsoft wants to make sure that you are not using it for any sensitive scenarios. So it should not be implemented like for doing diagnosis or for some scenarios, for some important scenarios where the decision is really important. So it's only for some kind of aggregation and gaining overall insights, like projects like the one I'm talking about. And what this service supports is essentially entity recognition, relation extraction, and linking entities to ontologies. So what we mean by that, consider this text, like ribavirin was also evaluated against SARS-CoV-2 infection, and so on. So you can see that if we give this text to the service allows us to extract entities, things like that. And it says that this ribavirin, for example, is medication name. And it also maps it to the ontology. There are a number of ontologies used in medicine. Ontologies are standard vocabularies which are used by everyone. And for example, if you are talking about coronavirus infection, there are different ways to say coronavirus. You can say SARS-CoV-2, you can say COVID-19, and those two terms, they relate to one entity, to coronavirus infection, new coronavirus infection. And that is why it's important for us to be able to map that to one entity. And that's why this ontological mapping is extremely useful and extremely important. So what another thing that is extracted by this service is negation. So for example, when I say something like this is established against SARS-CoV-2 infection, this SARS-CoV-2 is marked as negated. So we are referring to it in the negative sense. And then one more thing that this service can extract is relations. So for example, you can say that this symptom sore throat occurred at 2 a.m. this morning. And those two entities are related by the relation time of condition. So that is what the service can give us. And the next thing we want to do, we want to use this to apply it to the data set of COVID papers. So in order to do it, we install Azure Text Analytics SDK. And we need to make sure to grab the latest beta version of the SDK, because non-beta version does not yet have support for text analytics for health. So we pip install this latest version. And then it's pretty easy to use this service because, well, it's easy to use it from .NET. It's also easy to use it from Python. I will be using it from Python just because data scientists use Python, and there will be some more Python code coming. So that's why bear with me. Python is not a bad language. I, at some point, switched from .NET to Python and survived. So I hope you can survive my presentation as well. So what we do here is basically we create the object called client, provided the credentials which we get when we create this cognitive service resource in the Azure portal. And then we can basically just do one call. It's a synchronous call. So if I want to analyze it synchronously, I say begin analyze healthcare entities. Then I await the result. I say polar.result. So that's it, one call, and I obtain the list of entities. So for example, if I provide the service with this phrase, I have not been administered any aspirin, just 30 milligram of favipiravir daily, it will give me this object like healthcare entity, text 300 milligrams. So you can see that it extracted this 300 milligrams entity, and aspirin, favipiravir are medicines, and daily is the frequency of medication. So below you can see the relation. So for example, it understands that 300 milligrams refers to favipiravir, and it's related by dosage of medication. That's quite useful information because we are able to extract this like dosages automatically. So what we did to analyze the papers, we actually did not analyze full texts of papers. We analyzed abstracts to begin with. 400,000 abstracts we split it into chunks of 500 and analyzed each chunk independently using a set of virtual machines. So on one virtual machine, it would take something like maybe one day, like 24 hours to process. So we used like 4 virtual machines to process this data in parallel and end up with this JSON information for all papers. So this JSON information, as the result, it looks like this. So essentially ID of the paper, title of the paper, authors, journal, publishing time, and then list of entities, lists of relations. What to do with this information, to how can we query it or process it? Of course, we can process it manually by loading it into our program, but we can do smarter. We can upload this to Cosmos DB. Cosmos DB is the NoSQL database which can store exactly this kind of documents, right? So Cosmos DB is built around collections. So we have collection. And in collection, there are entities, like each paper can be represented by its own JSON document. And inside the paper, I will have a number of entities, and the entities would be related by relations. So that is pretty easy. I take the JSON from the previous step and I put it into Cosmos DB database. In Cosmos DB database, I can then do SQL queries. So for example, I can say if I want to retrieve different dosages of medication. So that is one common question that comes up, like which dosage of medication is applicable in which scenario. And I want to, for example, get all the papers where different dosages of, for example, hydroxychloroquine, which is one of the first medicines used to treat COVID, are present. So I can say I want to select the title of the paper and I want to select the source text, meaning the dosage, from papers collection, and I join the relations. So for each relation inside a paper, I would have a separate row, and then I select only those where the relation type is dosage of medication and the medication name contains hydro, so hydroxychloroquine. And I will get this list. You see, very convenient list of paper title and dosage. This is really cool because the person who does the research can immediately get the information that he wants. Let me show you how this looks in the Azure portal. So this is the Cosmos DB database. Inside Cosmos DB in the Azure Explorer, I have this data explorer. This is a beautiful interface here, which allows me to do many things. So for example, I can go to my papers collection, and here I can see items, all the items in the database, and each item is, as I mentioned, it's a JSON document like this. And on top of that, I can do SQL queries right here. I can say I want to perform new SQL query. And here I can say select and those on and so on. I will not do it for the sake of time, but you would know how to do it if you want. But that's definitely not enough for a medical person, because a medical person would not be able to do SQL queries himself. So we want to expose this information also by via some kind of easier interface. And this interface can be provided by Power BI. So Power BI is the solution for building like dashboards. It's a no-code solution, so you can essentially open the Power BI Explorer, say I want to connect to a data source, and you can build the dashboard. A dashboard like this. Let me show you the live Power BI dashboard, which we built for our task. So here, for example, this is the dashboard that explores entities. So on the left, I have different entity types. You can see that entity types can be diagnosis, for example, dosage of medication, frequency, gender, and so on. For example, let's see the diagnosis. If I click the diagnosis, you can see here there is a count, the number of times this entity appears in our data set. So diagnoses appear quite often. And when I click diagnosis on the right, I have all the entities of this type. So I have all the diagnoses in my data set. You see, the most important diagnosis is COVID-19. I don't know if it's visible for you. I'll make it larger. Oops, sorry, I clicked somewhere where I should not. Start again here. So I will select diagnosis, and here I have the most popular diagnosis. You see, the most popular one is COVID-19, and then SARS-CoV-2, which is essentially the same. On the right here, I have the ontology ID. So you see, they both refer to the same ontology ID. So it's essentially one diagnosis. Then there is a diagnosis called disease, which is not very interesting. Infection, pandemic somehow also made it to diagnosis. Then COVID-19 pandemic, and COVID-19 pandemic, you see, is the same as COVID-19. Coronavirus disease 2019, which is also the same as COVID-19, and then death, unfortunate diagnosis, and so on. Diabetes, RDS, and so on. And we can even pregnancy, you see, is the diagnosis. And we can, for example, knowing those entities, we can start exploring, for example, are there any papers that mention pregnancy and COVID together, and those kind of things we can explore. In terms of relations, we can switch to relations here, and let me show you the example that I have shown previously with the dosage of medication. So here I can say dosage of medication. I can select this relation, and on the right I can see all the medicines and their dosages, and that is also sorted by count. So for example, you see that hydroxychloroquine and 400 milligrams was mentioned 51 times, and HCQ, it's the same as hydroxychloroquine, was mentioned another 49 times, and then 200 milligrams mentioned 46 times. And those kind of things you can view automatically using this dashboard. So this dashboard can be provided to a medical person who studies this matter, and he can explore and he can gain insights. What would be nice to add here, which we did not have time to do, is to add also paper titles. So from here, for example, I can see those 51 papers which mention this dosage, and like click there and get to the abstract immediately. That would be really cool thing to add to this dashboard. But the dashboard is good for exploration, but how about gaining some insights? For example, one thing we wanted to learn is how treatment strategy for COVID-19 changes with time. You know that hydroxychloroquine was popular in the beginning, and then there were other more effective medicines discovered. So in order to do those kind of investigation, what we did is we used a Jupyter Notebook, the interactive notebook, which you can use with Python, for example. And in Cosmos DB, there is a built-in support for Jupyter Notebooks, which allow you to use SQL queries as well. So what we did, I will show you how it looks in Cosmos DB. Here in Cosmos DB, you can go to Notebooks. And notebooks, they look exactly like normal notebooks. You have pieces of text and pieces of code. And here, for example, I can say, I want to run this query against the database. And what this query will produce is it would produce this table, which is the in-memory table on which you can further operate using this notebook. So for example, here, this table mentions all the publications, the ID, the ontology ID of the medicine that is mentioned there, and whether it is negated or not, and also the name of this medicine. So what I can do, well, this just the frequency of publications per time. That's not very interesting graph. But what I can do then, I can group all the medicines by their ontology ID, so that I group all hydroxychloroquines together, whatever the word was used to mention it, and count the number of papers that this medicine occurred in. So you can see that hydroxychloroquine occurred in 4,800 papers, and 200 times in a negative context. And you can count kind of negativity index of every medicine by dividing negative by positive mentions. Having done that, we can select top 15 mostly mentioned medicines. I excluded the ones like epidemic and quarantine, which are not exactly medicines, and came up with this list of 15 medicines. And for them, we can build this table of occurrences with time. So I have the months and how many times this medicine occurred during a specific month. So that allows us to plot the graphs like this. By month, the number of mentions, positive and negative mentions. And you can see that, for example, for hydroxychloroquine, the number of mentions declined. And by the way, this decline was in spite the number of publications increasing rapidly. So this is absolute value, not the percentage. The percentage would see even faster decline. So interestingly enough, you can see that hydroxychloroquine therapy and chloroquine therapy is becoming less and less used. On the other hand, favipiravir, which is one of the prospective medicines, is gaining popularity with time, and also other things like remdesivir and azithromycin. So this is quite useful information already, right? So we can explore this statistical data. That is really cool with notebooks. You can do even more interesting things. For example, you can try to calculate the frequencies of terms appearing together in the same paper. So for example, this diagram which is called Sankey diagram, allows us to see, for example, in COVID-19, you can see that prevention occupies quite large portion of publications. And then in addition to prevention, like supplemental oxygen is discussed, mechanical ventilation, masks, social distancing, antiviral medicines and drugs. So this is not the specific medicines here on the left, but types of treatment. So different types of treatment. And interestingly enough, more papers discuss prevention than actual treatment than drugs, right? That is probably because there are also a lot of papers on COVID pandemic spreading, like predicting how fast it would spread, doing those kind of things. Those are also included into this data set, not only papers on specific medical treatment. You can, of course, build the same relations for other types of entities. For example, this is the relation of diagnosis and medicine. And you can see with COVID-19, hydroxychloroquine is and lopinavir are the most popular. Then quarantine is also very popular as a medicine, and you can see the popularity of others. Well, I mean that is through all the time periods. Of course, if you want, you can build. Like you can take only certain time period, like last 2 months, and see how this diagram looks for most recent papers. What would also be interesting is to see co-occurrence of different terms. So, for example, you can try to see the co-occurrence of different medicines. And if you do this, this is shown here in the left diagram. You can see that the combination of chloroquine and lopinavir, which is one combination which was quite popular, and hydroxychloroquine and azithromycin, another popular combination. And you can in fact see that on the diagram, how often different medicines are suggested to be used together. Well, to be fair, not suggested to be used together, but occur together in the same paper. Unfortunately, to gain better understanding, like do people recommend those medicines together, or do they recommend to compare them, or do we recommend to use either one of those? That is not quite clear, because relation extraction works only to a certain extent. Like it can extract relations like dosage of medicine, but it does not extract like relations between two different medicines even in the same sentence. So to take full advantage of this technology, of course, we probably need to build some deeper language understanding. Of course, we can do that. We can try to train our own neural network to recognize different intents, like what this intent in the phrase means. Like, does it mean compare medicines? Does it mean use either one of them? We can, for example, use cognitive services for health to extract sentence with name of medications, and then within this sentence try to figure out relation between them. So there are many approaches. We can go deeper into semantical understanding of the text. What I have shown is the first approach towards that, and the approach which is already quite efficient and quite easy to implement, in the sense that this did not require a lot of programming, as you have seen, because we used the pre-trained service. If we wanted to use our own like trained neural network, we would require a data set. So I think that, as always with artificial intelligence, there is the problem that to train something you need a data set, and there are not many. Like there are some data sets publicly available, but not too many of them. So we relied a lot on this service. And actually, behind text analytics for health, there is a network called PubMedBird, which is available in pre-trained form. Microsoft Research released it like several months ago, something like half a year ago. So that was my demonstration. So I think the main idea that I want you to take away with this is that text mining is really good for mining big portions of texts in any domain. Like in medical domain, that's especially good because there is already a specified, specialized cognitive service for mining text entities in medicine. But general text analytics cognitive service can extract some other interesting entities. So if you have texts in some other area, you can also try this approach. And interestingly enough, a lot of different technologies being used together allow us to achieve our result very fast. Like comparing if we wanted to do all that by hand, like imagine even doing the queries and all those things by hand, that would be definitely much more complicated than using specialized services on each step of this journey. And that is what cloud allows you to do. Cloud allows you to do, it contains like specialized platform services for whatever task you have in front of you, and by putting them together you can solve your problem very easily. So I have something like 2 minutes left. I guess the question that you might have is, can we do the same from .NET? And actually most of the things here you can do from .NET, because I did not use anything really too Pythonic apart from maybe drawing diagrams. Drawing diagrams in .NET maybe is not as powerful. Like I don't know if the libraries uh, there are third-party, I just forgot the name of .NET visualization packages. I wonder if they include those kind of Sankey diagrams, but if they do, that would be also quite easy thing to do. So so you can theoretically do all this thing in .NET as well without many complications. And that's it for my talk. Thank you so much for bearing with me during this time. If you have any further questions, or you want to collaborate on this, you want to do something similar, you can reach out to me, and my contact information is here on the slide. Thank you.
Thank you very much, Dmitry. Really inspiring session, and yeah, I think these services you demonstrated are really awesome, and will help to solve a lot of real life problems. And I think we have 1 minute for answering the question. So we have Slido tool to send us a service for sending questions to our dear speakers. And the question is, could you please provide an example for UMLS mapping to ICD-11 codes, considering Azure tools usage?
I'm not sure I am qualified to answer that. So because what we used in our example, we used UMLS ontology. Text Analytics for Health provides mapping for several different ontologies. So what it does for every entity, it provides the list of mappings, and you can just select whatever ones you want. So for how it does mapping for specific terms, that requires, I think, further investigation. So I would not answer that just out of my head, if I understood the question correctly. Yeah.
Fair enough. Okay, Dmitry, thank you very much, and talk to you later.
Thank you. Yeah, have a great rest of this conference.